Hello everyone. So today we are going to go over section 6.3, modeling data with a line of best fit. This used to be a section that was done using a graphing calculator, and the instructions on the front page here, this part, was for graphing calculator use. This section has since been modified to be done without a graphing calculator, so we're going to go over how to do that today. Okay, let's look at some example. Example 1. It says here the 1 hour record for the farthest distance traveled by a bicycle in 1 hour is recorded. So that's the year and the distance. Now you can see the numbers for the year start at 1996 and goes all the way up to 2009. So what we can do here is instead of dealing with numbers in the thousands, we can think of it as number of years since 1996. And that's once again years since 1996. So of course, the first number here we have 0 years since 1996, and then 98 was 2 years after, 99 3 years after, and so forth. We have 6, 7, 8, and then 2007 was 11 years since 2006, and then we have 12 and 13. Now for the distance, there's not much we can do. We're not going to subtract and say distance more than 78.04 in this case. We're just going to leave it as is. Now what we're going to do is we are going to go to desmos.com with a graphing calculator. And once we are there, we're going to go to the add item option. We're going to add a table. Okay, so the table is already labeled as x1, y1. We're going to enter the years since 1996 as our x variable because, of course, the distance traveled is dependent on the year. Okay, so we will have 0, 2, 3, 6, 7, 8, 11, 12, and 13. And then, of course, we're going to enter in the corresponding y values. I'm just going to go ahead and do that now. So one of the things you want to make sure you do is be very careful when you're entering these values, because if you make a mistake, then your line of best fit is not going to be the correct one. Okay, so just about done here. Once you have the numbers put into a table like we have here, you don't see any of the points yet. So what we want to produce is a scatter plot. So we're going to go to the graph settings here on the top right, and we are going to change the maximum and minimum x and y values so we can see the points that we have drawn. So choose some numbers that will be closer to what we have. So for x values, we're going to go from -1 all the way up to, like, say, 15. And for the y values, we can start at maybe 70 and go up to 100. So once you do that, oh, there's a mistake somewhere here. Right, 0.3 is 81.16, not 91.16. Sorry about that. So you can see our 9 points, our 9 data points are here on the scatter plot. Okay, so now we are going to use, if you look at the notes, says to use technology to create a scatter plot, which is what we have done, and then we're going to determine the equation or line of best fit. So what Desmo and used to be graphing calculator allows us to do is to find the true line of best fit. So whereas before in some science experiment, you will plot, let's say, distance over time, and then you will draw by hand a line of best fit. But there's a systematic way of finding the true line of best fit, and that's what the graphing calculator, or in this case Desmos, would do. So how do we do that? We're going to go y_1. Notice that Desmo immediately recognized that as our distances, right? The 9 elements list. We're going to go out of subscript mode, and then tilde, and ax_1, and then out of subscript mode plus b. So notice this format right here is very close to y equals mx plus b, right? That tells Desmos that we're looking for a line of best fit, and we want to know what the slope and the y-intercept are, so we will know how to graph it in the future. So there's some numbers here for statistics, right? We have r squared and r value. We can plot the residual. We don't need to do that right now. We're just looking for the parameters a and b, which once again tell us what the slope and y-intercept are for our line of best fit. Okay, so once you have those numbers, you just need to record those, round them to the appropriate number of the decimal places. In this case, 3 decimal places. So the answer should be y equals 0.858 x, that is of course our slope, plus, and then 77.794. All right, so notice that there are some years that are skipped over. So for example, there's no data point for year 2000, 2001, there's none for 2005, 2006. So if we're going to interpolate a possible world record distance for 2006, and if you read above, it says here, interpolation is the process used to estimate value within a domain of a set of data based on a trend. So the trend, of course, is our line of best fit. The domain is the data points that we already have. So no lower than 1996 and no higher than 2009, or 0 and 13. So is there a nice way to do this on the graphing calculator or Desmos? Yes, there is. But the first thing we need to do is to examine, well, the year 2006, that is 10 years since 1996. So when we interpolate, we're going to let x equals to 10. Okay, so let's go back to Desmos. We can simply open a new table or function here. We can add a new item and simply let x equals 10, which will produce a vertical line. And the intersection between our line of best fit and this vertical line right here, that will tell us, based on the line of best fit, what the possible world record for the year 2006 would be, and it was 86.379 kilometers. So we can go back to here, and we have the corresponding y value would be, once again, y is equal to, and it says to round to nearest 100, so maybe 2 decimal places would be better, so 86.38 kilometers. So that's the process, right? You enter the data, you use what's called linear regression to get a line of best fit. You write down what it was, and then you answer some questions, whether it's interpolate or extrapolating, and that's it. So usually you'll be given an x value and you find a corresponding y value, or vice versa. Okay, let's look at the next one. So for sometimes you're going to have data that don't have any headings. It's just x versus y. So let's go to Desmos. So anytime you're finished with one question, you can just delete all of the items that you added, the table, the regression, and any of the vertical or horizontal lines that you have added. You can make new ones. So in this case, we are given, so we make a new table, x1, y1. So it was 0, 2, 4.5, 5.2, 9.5, 12. And then we can enter in the corresponding y values. Okay, like so. So once again, the points don't show up because our y values are too large now on our graph settings here to the right. So we're going to change that. We're going to let's say, the smallest y value be -1, and we can have it go all the way up to maybe 15. So long as all the points fit in the graphing area. You can see all of them. So we have 1, 2, 3, 4, 5, 6 points, and they look to be very linear. So once again, we can go to the second part here, y_1 tilde ax_1 plus b. So in this case, our parameters a and b were 0.693 and B value was 5.183 if you round it to 3 decimal places. And once again, that's what we'll record here. So we have y equals 0.693x plus 5.183. Okay, so that's again the equation of the line of best fit. Okay, the next part, it says to determine to the nearest tenth the value of y when x is equal to 10.6. So that's something that we're familiar with. Let's go back to Desmos, and we're going to enter in x equals 10.6 and see where it intersects our line of best fit. Looks like y is equal to 12.5 here. So let's go ahead and record that. And likewise, for the second part, it says determine to the nearest tenth the value of x and y is equal to 9.8. So we can just go make a new line, let y equals to 9.8. Now we have a horizontal line that's in blue, and looks like the corresponding x value, if you round to one decimal place or to the nearest tenth, x equals to 6.7. Okay, so just one more quick example here. We're looking at extrapolation. So it's the process used to estimate a value outside of the domain is based on the trend. So it's still based on the line of best fit in this case. But of course, extrapolation assumes that the pattern is going to continue. Maybe it doesn't. We don't know. So let's look at this example here. Matt buys T-shirts for a company that prints art on T-shirts and then resells them. So the T-shirts would be bought in bulk, right? Okay, looks like it. And the price per shirt, or the cost per shirt, is related to the size of the order. So here's some examples right here. In this case, Matt has misplaced the information from the supplier about the price discount, so he needs to find out what the price discount is. And he's trying to get the price per shirt to be below $1.50. Okay, so let's look at this example. Once again, we're going to go back to Desmos. We're going to delete everything, all the items that were there before. We're going to add a new table. Our x values were the number of shirts because the cost per shirt is dependent on the order size of the order. Okay, and then the y values corresponding. Oh, sorry, 1.95, 5.2. All right, so again, the numbers or the points don't show up right away on the graph. We have to change graph settings. In this case, consider that the smallest x value is 200 and the largest x value is C 740. So maybe we can just make it 1,000. Right, something like that. Now you can see all the points, and then the y values doesn't have to be so high. Maybe just 6. Right, so we have 5 points here. That's good. So once again, we will form our regression. Y underscore 1 tilde a and then x underscore 1 plus b. That's the format. You can see in this case, we don't really talk about it, but the r square value is 1. And you can see that the points match a line of best fit perfectly. So of course, the higher the I value, the higher the correlation between between two variables. So the fact that r is in this case -1 means as x increases, y decreases, and which makes sense because the more shirts you buy, the less it costs. But that's beyond the scope of what we need to be doing right now. So let's go back to the function. We have the a value is negative 0.0065 and the b value is 6.5. So let's write that down. And we're also going to try to interpret what those two things mean. So here we have y equals to negative 0.0065x plus 6.5. So we know already that x is the number of shirt spot, and that will tell us y, which is the cost per shirt. All right, the slope in this case is the rate of the cost decrease or the rate of discount. And the y-intercept will tell us what the base cost was if you ordered very few shirts. Right? If you order 0 shirts, and the cost per shirt would be $6.50. Okay, so last little part where we are going to make the assumption that the trend holds, and we're going to extrapolate. We're going to find out what size order it must be to achieve the price of $1.50 per shirt. So let's go back to Desmos. We're going to set y equals to 1.5, and here it intersects, and you can tell that x is close to 770, so we can just say yeah, 770 shirts. And that's it. So that is how you use the Desmos graphing calculator to find the lines of best fit. And we can also answer some questions about them and learn how to format data points in some cases to make them a little bit easier to work with. So next day, we're going to look at other regressions, quadratic and cubic as well. But that's it for today. Thank you for listening.